Okay, are there any questions about anything? Coursework questions? What's your name?
For the Excel file, there's already some words in there, and there's a 500-word limit. Yeah. Are there current like descriptions? Do they use the word pattern?
Which descriptions?
I'll see if I can get up. But in the Excel,
There's a weekly file, right?
yes, but there's also the Excel file.
Okay.
It has things like what you program, what code marks, have you done it, and write a description about what your program. And like, how have you refactored everything, have you done unit tests? Do the things which are saying, okay, this is what you thought about, do those count towards the 500 word limit?
I don't think I understand the question, actually. What are you looking at exactly? The coursework specification, yeah?
Yes.
Let's see, is it here? Okay, which part are you looking at?
In the claims list, page 3, well, the end of page 3.
End of page 3.
Yeah. So there's
Okay.
claims list.
Claims list, an Excel spreadsheet called using the provided marking scheme. Okay. Documenting your claims, providing your maintenance activities, and first you know how you did it and where you can find the evidence. This information needs to be justification. The overall word limit is 500, so keep it concise. This is the most important document of your coursework, so take extra care when you write it. Okay.
Yeah, in the document already, there are things describing, there's a thing describing what you should talk about. Do those things count towards the 500 marks?
How many words are there already?
I'm not sure. I'll count and get back to you.
Yeah, that would be good. But I think it's fine if you add, my guess is that you can add 500 additional words as
Yeah,
to what's already there.
that's what I think, I just want to make sure.
Yeah. Any other questions about the coursework or anything? Zach?
How do you undo a merge? Like, say if you merge incorrectly, how do you undo that merge? Go back to previous ones.
In your Git, you mean? So you can't, there's no undo in Git. Like, if you think about it, undo would be like erasing history, but the whole point of Git is to preserve the history. So you can't just undo. The only thing you can do is check out a previous version, the one that works, if you know what I mean. So you can't erase something that's broken. It's there. You can just check out a previous version that works. Does that make sense?
That does make sense.
Okay.
Say if you want to move forward and you checked into the previous version and made a separate branch to that previous version, you just continue onwards there then?
That's right, yes. Any other questions?
Would you get
Zach.
less points because you kind of messed up your get?
No, there's no point lost if you want to. If you check in something that's broken and then you go to a previous version and keep working, there are no problems. That's not a problem at all. That's partially the reason we're using Git and version control in the first place, because this sort of stuff happens a lot. Like, that's part of the purpose of version control. Yeah, so there's no points deducted for that. Yeah. Any other questions? Anybody have questions that they're too afraid to ask in front of the class? I like it when people ask their questions in front of the class so that I can answer to everybody and rather than one-on-one. Some of you may have noticed, like, I say, like, can you ask this question in class or in the lab or something like that? Because imagine if I only answered individually, imagine like 250 emails coming in and I just write one by one. Like, that would be bonkers. That would not be efficient. And it wouldn't be the best learning experience either, right? It's not getting the most of your education if I do that. Okay, if there are questions, feel free to interrupt me anytime. I don't mind being interrupted. And if you have comments, you're welcome to interrupt. I think I am picking up a signal from the audience about I'm picking up like this signal that somebody does have a question that they're too afraid to ask. But I can use my beginner level psychic powers to read the questions without even them being spoken aloud. Somebody is wondering, do you still have any leftover Halloween candy? Bob, but they were too afraid to ask. Am I correct? Somebody was wondering that? I think at least one person in the audience. The answer is no, I don't have any more leftover Halloween candy. Okay, so we're going to talk about libraries and open source software today. So using libraries, we're using libraries in this project, this snake game, right? So this is a topic you're already very familiar with. The labs for the next 3 weeks are going to focus on the coursework, right? So there will be very special exercises. And in the very last week, there'll be sort of a time for your coursework and exam revision. We are going to talk about exam revision in the coming weeks. So just some tips on the coursework. Have a look at these screen capture demos. We worked hard on these screen capture demos. They took a lot of mistakes. You don't see all the mistakes, but we only publish versions that actually work in the end. But have a look at those. If you're running into trouble, look at the setting up Git and GitLab. That should be done already by now by everybody weeks ago. There's a screen capture demo on setting up a Maven project, a Gradle project, a Java FX project, using Maven, by the way. Have a look at those. They have tips in them, like which versions work, which versions don't work, and so on. There's a screen capture demo on setting up JUnit testing within a Java FX project using Maven. It turns out it's a little bit tricky in my opinion. And then follow debugging guidelines. Also, what I often forget is the more complicated screen capture demos have the steps in the descriptions of the videos as text, right? So if you get stuck, you can look at those textual descriptions. And I find that this slide, basically, if you can absorb the information on this one slide, you will solve so many of your problems. This slide is not very complicated, but there's a lot of information actually here represented here on this slide. And all the questions I get in the lab, almost all of them can be answered by the information represented on this slide, actually. And we're going to talk more about that, actually. So we're going to talk a little bit about the philosophies of software development. And so you'll work on lots of different projects during your career. Well, if you enter this career, right? Some of those projects may use open source code or open source libraries, and you may develop private code to be open source or vice versa. and we'll look at this third-party code in this project. I think you'd be surprised at how many projects use open source software, including commercial products that are sold. A lot of commercial products that are sold use open source software. The last commercial product that I worked on and was sold used an open source software library called Fox. A library that you'll never use in your career because it's just not that great of a, it's not like the best library ever, but it was an open source library that was incorporated into a commercial product. So this is something I think everybody is familiar with. What is a software library? It's a third-party software packaged and ready to use in your application. So it's reusable code. Essentially, that's what it is, right? And the goal when you develop software is to produce reusable components. That's like that message hopefully has been drilled into your head quite a lot during this module and during your degree, right? So the ultimate software can be reused over and over again. So you could write classes for your snake game, and they could be reused over and over again in other software applications if you're doing like a really good job. They're usually accompanied by online documentation, right, like Java docs, and you've already seen this, right, in your courseworks, like the JUnit libraries, for example. The snake game has some libraries in there. So libraries usually consist of a jar file, in the case of the Java programming language, right, created using a jar tool, right? IntelliJ actually will let you create a jar file. So if you actually wanted to write a library and release it, then you would create a jar file. You can package a bunch of classes together, right? And there's a special folder that they all go into. This is something after compilation. So the theory with Java is compile once, run everywhere. Has everybody heard that theory before? So in theory, you compile a Java file, a Java program once, and it runs on all the different platforms. That's the theory. I'm not sure if that works in reality. So you can distribute binary files. In other programming languages, you might need to compile that software specifically for your operating system so that it doesn't crash, right? That's called pre-compilation, right? Publicly accessible methods, and so on. And there's usually some sort of a license that describes how you can use the software. Right? A lot of times it says something like free for educational purposes and research purposes, but it costs money if you're using it in a commercial application. So to make use of the libraries, we often need a jar file. Theoretically, this is what Maven and Gradle are good at, managing these dependencies when you need an external library, right? You need to add it to your Java build path, and then you import the relevant parts of the library into your code, and you make use of the methods that they offer. And there are two ways to deploy them, so to speak. Imagine you were going to release your snake game as a product to the world, right? You could package those external libraries with your application, right? That's what this describes. But you could also just distribute the build files that say, okay, download these external libraries and use them in your application. So you don't have to actually package them into your application. In Maven and Gradle, external libraries are included using these so-called dependencies. And in the screen capture demos that I alluded to earlier, you'll see examples of including dependencies in Maven and great little projects in those screen capture demos. Build systems can pull required libraries from remote sources. So when you're doing something new in IntelliJ, like making a project for the very first time or a Maven project for the very first time, you can see it downloading software in the background, the libraries it needs in the background before you actually can do it. And in the Git screen capture demo, I think I waited for like 10 minutes while it downloaded lots of libraries to get that working initially. And of course, these are placed in special folders, right? These are folders that you don't normally see, right? The folders that start with the period. You can request particular versions of libraries and see different versions of libraries in this folder. And in the screen capture demo of, I can't remember which one it is actually. I think it's Maven. You see like lots of different versions of JUnit library. So you can see those screen capture demos and have a look at what setting up a dependency looks like and all these different versions of the libraries. I think one of the challenges here is just that there are so many external libraries now, it's hard to know which one to choose. I think this is a major challenge. So when you do a search in Maven for the dependencies, I don't know if anybody has tried that yet, but that list is endless of plugins and libraries. It's very long. Okay, so I'm not going to spend a whole lot of time on that because I think that conceptually that's a very familiar topic. Is it Sean?
Yeah.
Sean.
Isn't using libraries can also lead to like vulnerabilities? Because there could be vulnerability for Java, like log4j recently because there was a vulnerability in some library which affected a bunch of different systems. Because you just blindly were like, this is safe code, we believe that this is what we need and it's perfect.
Definitely, libraries can definitely be a vulnerability. And one of the pains with libraries is when they get updated and you're supposed to update your software to include the latest version of an external library. So that's
not always the right answer.
Yes, exactly. So it can be a pain. Like the ideal, like, okay, I can tell you what I've done personally. Sometimes I thought, wow, this library is so huge. You know, it's whatever number of megabytes, and it's so complicated. I just want this one method. And if it's open source, I will just copy and paste that one method and say, here's where I got it. Because I don't want to think about this, I don't know, 50 megabyte library that's so complicated. Maybe you have a method and it has like 10 parents, and you just don't want to take the time to understand it all. You're just like, I want this one method. One of the examples I can think of is one of the things that's really difficult is testing, making a test that's if two lines intersect each other. It turns out that this is complicated, especially in 3D space. And so I don't know how, I didn't want to do that from scratch. I'm like, somebody must have solved this problem before. So I looked and I found a method that tests if two lines intersect in 3D, but it was part of a big library. And I was like, no, I don't want all this. I just want this one method. So I copied and pasted that method, and I just put a link to where I got it. So certainly that's true, yeah. Yeah, so every time you add a library, it makes everything more complicated, definitely. And they have a learning curve associated with them too, those libraries. Okay, we're going to talk a little bit about open source software. I think everybody is familiar with this. Anybody not familiar with open source software? You're using it on a daily basis if you didn't know already. Open source software is generally free software that uses any license approved by the Open Source Initiative from their list of approved open source licenses. We're not going to talk about them all in depth. We'll just mention a few. So what is free open source software? Software that gives users rights to run, copy, distribute, change, and improve as they see it without asking permission from or making payments to any external group or person. I mean, there was a time when this didn't exist, right? This concept of open source software didn't exist. And it's a great discussion and it's a great philosophy. You know, it's if you think of a car analogy, when you buy a car and it breaks, should you have the right to open the car, the hood of the car, and fix it yourself? You know, so that's a debate. Some people think no, and some people think yes, and this is very similar. If you download software and you pay for it, for example, are you allowed to fix it when it breaks, for example? Or another case is, okay, my car broke and I want to see what that part is that broke. Am I allowed to see that? You know, if you use the car analogy, it's pretty shocking to say, oh no, you're not allowed to open the hood of your own car and see what broke and why it broke. That would be kind of a strange thing to say. I think there would be massive protests. But there was a time when open source software was not such a popular concept, and commercial vendors of software were saying, no, you're not allowed to see the software. We're selling it to you. You pay for it. If it breaks, you pay us again, sort of thing. So it's an interesting topic, let's just say. And this idea that all software should be open and legible was not always around, this idea. Right, so there's a famous person, Richard Stallman, the president and founder of the Free Software Foundation. And there's the concept of free and open are not exactly the same, by the way. Right? Free means you're paying for it, open means you're allowed to read it. You could have free software that you're not allowed to read. That's possible, right? Or you could have open software that you pay for. So all of those combinations are possible, right? So free software should be a human right is the perspective that Richard Stallman comes from. Open source software is software generally that you can read, right? That you can actually see the source code and read. And it offers some advantages. For example, higher quality, it's customizable. In other words, you can change it, right? It can be improved. It's more collaborative, right? Anybody can look at it. It's easier to redistribute. It's more transparent, and it's usually free. I mean, if you are writing software and you know that you have to publish it, I taught a class, by the way, where it was a requirement to publish your software. That was like part of the requirements. Not in this module, but in a different module I said, part of the requirement is it has to be open. Everybody has to be allowed to see what you submitted. There were some objections to that. But if you know that what you're writing is viewable by the world, then chances are you're going to try harder to make it good, right? You're going to try harder not to include quick and dirty hacks and things like that and bad practices. And this is also recognized as a good thing by some industries, right? There are two sides to the coin, right? But I think over time, more and more industries recognize the value of this idea, right? It can be good advertising. It's also generally accepted as being more secure. Can anybody remember that web server example that I I showed with Linux versus Windows. One's open source and one was closed source. And the open source web server is generally seen as more stable, right, and more secure. So, and also, some people believe that, this idea of using open source software can attract more talented developers to your company. So when I said you're probably using it every day, here are some examples. The Linux operating system, right, is probably the most famous example. OpenJDK, Apache, this is the world's most popular web server. Right. LaTeX is an example. Anybody use LaTeX yet? You guys using that? Moodle, that's a kind of interesting example. Firefox, Android, Mozilla, MySQL, OpenOffice, Blender, VLC, IntelliJ, and Eclipse. So those are just some examples. Right, but I think there are lots of people using Android and lots of people using the Apache web server, whether or not you know it. Right? And there are companies using open source software, right? You've probably heard of these: Adobe, Docker, Facebook, GitHub, Google, Gradle, and so on. Look, there's one you probably didn't expect to see. Right? Microsoft used to be a very anti-open source software advocate. Used to be strongly against that. Does anybody remember that? With Microsoft?
Called like open source software cancer.
Yeah, times have changed. Times have changed. There was a time when they were heavily against the idea. Anybody know who Steve Ballmer is? That's probably too old, too long ago. You remember who's? He's a former CEO. If you go onto YouTube, you can find Steve Ballmer calling open source the cancer of software. Do you know about that? How do you know about that? These were the dark days of Microsoft. Anyways, so it's very popular. There's a set of criteria that is published in order for something to be called open source, right? And there's lots of, like, let's say, adoption. What I described a few minutes ago to Sean was just copying and pasting someone else's method and then saying where I got it from. Right? Code adoption can happen at the level of lines of code, a method, a class, a library, or a component, or a complete system. Does anybody know does anybody know Internet Explorer? Does that still get used? Is that still alive? Internet Explorer, or is it dead?
I think it is deprecated at some point. It's pretty dead.
It's dead now? Is it officially dead? Like, is it gone?
And Internet Explorer mode in the page, and that's what about it.
That was one of the most interesting chapters of the sort of open source history, in my opinion. There was a browser war for some time when the web browsers were first getting popular, so there was a competition to see who could make the most popular web browser. And so Microsoft released Internet Explorer, but Internet Explorer was built on top of an open source web browser called Mozilla. That's going way back. But if you looked, unfortunately I didn't take a screenshot of this. I wish I didn't know that this was gonna die. But if you looked in the About menu of Internet Explorer, you could see the Mozilla roots there. So that was kind of an interesting time period, because on the one hand, Microsoft was saying, oh, it's the cancer of software, but on the other hand, they were using it as part of their web browser. Here are just some examples, you could call it a case study of setting up an infrastructure in a company, a small company, with open source software, right? You have a firewall typically, dividing you and the rest of the world, or the rest of the world here and you, right? You have a web server, an email server, a VPN, a name server, and so on. You have your version control, a search engine, a database server, and even a bug tracker. This is for a startup software development company. It's just a schematic view of different software components that you'll need to set up your startup. And then this is the same version, but with the actual some open source software recommendations, like IP chains, Apache, everybody knows. There are open source email servers, right? You already know about, this is a little bit outdated, I should say GitLab and GitHub, right? Everybody knows that there are open source database applications and so on. So that's just some examples of actually setting up your internet startup company with open source software. And this is a higher education setting. This is very similar, right? You have a firewall, you have a web server, a dynamic pages engine, database, an open source file system, file synchronization, open source version control, and this is the same one with the different components filled in with actual open source software applications. Those are just some examples of, you can call them case studies of open source software configurations, getting things done. And this idea is an ongoing debate, like the pros, the advantages it offers, the disadvantages it offers, and so on. You can look at it from an ethical perspective, and that's very interesting. And here are some articles that discuss the ethical sides of open source software. Right, this is a very long article here that starts with the definition of ethics and then makes a comparison of open versus closed software. And here's another viewpoint article. I've tried to summarize it in 3 words. Sharing is good. It's very long, but the basic view is that sharing is a good thing. Like, that's where you get the most benefits as a whole when you share. And here's some like, let's say, points of view that are not so obvious, like maybe some disadvantages of open source software. For example, the developers of a project might not be diverse. It might be a very focused, concentrated set of developers. I think Linux is a good example of that, right? It was started by one person. And some people argue that it's only the wealthiest that benefit from open source software. It's a point of view. And the example I gave just a few slides ago was Microsoft, right? Microsoft is a good example of the wealthiest inheriting and benefiting from open source software with their web browser. Sean?
Why is it bad that just Linus Torvald created Linux? And not
Well, I try not to use the word bad.
But
As
we
it,
try not to imply that.
the argument there is that diversity is good. And so if it's not diverse, it's not as good. That's kind of the viewpoint that article. But there's a link to the article if you want to see it in detail, like the different views. I mean, if the other counter argument is, well, it takes a lot of work and dedication. So it's not like Linus Torvald says, I'm going to make an effort so that this is not diverse. It just happened to be that way because he was this special guy that was determined to get this this movement going. So it's just by accident, really. Well, whatever you want to call it. It wasn't designed like that intentionally. But I think that as let's say a user, certainly the idea of open source software is beneficial. Like if somebody tried to sell you a car and they said, sorry, you can't look at the engine, you'd just be like, really? You wouldn't choose that car. You'd be like, okay, I'm going to buy a car where I'm allowed to look at the engine, right? You wouldn't. So from a consumer and a user perspective, certainly the advantages are high. I mean, it's like the natural reaction is, okay, what are you hiding? What am I not allowed to see? And that automatically makes you want to see it more. Right. And there are some like ethical considerations, right? This isn't just one article that I sort of was thinking about. Did anybody remember this? This isn't from that long ago. BMW recalling 61,000 cars due to a software error. Right, that's not going to be open source software. I don't know if anybody remembers this story, but there was some controversy surrounding this story. Like, well, if the development was open source, then this error wouldn't have happened. Like there was a person that did something maybe not ethical, right, which is not too shocking. And so I just thought this was an interesting real-life example of some of the consequences, the legal, ethical, and those sorts of angles on software development. Especially when it comes to these instances where you're writing software for something where safety is super important, right? Planes, automobiles, trains, any mode of transport, basically, the safety becomes ridiculously important. Even the new iPhone, I forgot about that story. Did anybody hear about the new iPhone feature with the new emergency call feature? Some of the disasters that happened already with that. I believe ultimately it will be a very good feature. This emergency, like auto emergency texting and calling. Did anybody notice that? You saw that story?
Isn't it like it detects if you're in a car crash or something, but there were tons of false positives?
That's right, it was returning false positives when people were on a roller coaster. Which is really, it's not good. I think they will work that out. But that's another example. And so even with the mobile phone, like it's, there are very serious consequences. Right, this is another one about Tesla and software. But I thought that Tesla did have a different policy when it came to software. I'm not sure if they have open source or closed source software. But I think the disasters like this are less likely in the case of open source software because people have a chance to look and see. Sean?
But doesn't also open source software have a different problem, which is that anyone can now put code in. Either they could maliciously add vulnerabilities or just not everyone's equal. They could just make a mistake.
Yeah, that's true. That's true. I haven't really heard any famous examples of that happening, but it's true. Somebody could try to put something malicious in there. Yeah.
I mean, there was an example of that university. I mean, this is kind of not really the same point, but there was that university that tried to add a vulnerability to Linux, and they were banned because it was a test paper or something.
I don't know that story. Do you remember the university or anything?
Well,
there were lots of, interesting stories. The stories that I find the most interesting are the projects that fail. Right, these projects that are really huge, very expensive, and then they fail. Like, for example, Internet Explorer could be, or Hotmail, right? These kinds of projects.
The University of Minnesota.
The University of Minnesota, okay, that's really interesting. I don't know about that story, but it sounds really good. I'll have to add that to my slides. Okay, and just a little bit of information about software licenses, which is very closely connected to the open source software. If you want to give your software away, you probably want to associate it with some sort of a license that describes what are the rules, what are you allowed to do, or what are you not allowed to do with the software. Right, if I'm releasing some software and somebody else uses it and they have a problem, like whose fault is that? I don't want anybody to sue me. Right, there's a good way to handle this problem, by the way, is to not release your source code under your name, but under a company name. So they have to sue the company and not you personally. Anyways, that's a different story. And maybe you also discover that you wrote software that's extremely useful, extremely successful, and it has a wide user base, and you think, oh, I should probably make money from this, right? Which is also a very valid viewpoint. And that's an argument against open source software. It's like, hey, I worked very hard on this, I want to sell it, I want to run my business on it, I don't want people to be able to just copy this and steal this. So that's a very valid viewpoint on the other side of the equation, right? So software licenses can protect you and your code or protect future developments. And they generally bring a little bit of order to the chaos. Like what they establish what can be done, who can change it, how can it be distributed, are there any warranties or disclaimers. These are all specified in software licenses. And these are some popular ones, open source software licenses. These are, if you want to see more information, these are some links. The so-called permissive license. So you can use this open source software, create a closed version, a closed product, and then sell that software, right? I think Internet Explorer is probably a good example of that. Copyleft license, any subsequent versions are left with the same rights, the same source code must be supplied and can be modified. So in other words, when you use that software, you're not allowed to change the license. The license remains the same. Here are some examples. Right, Apache has a special software license. BSD, a special version of the Linux operating system. And by the way, Apple switched to a Linux operating system, right? That story goes back a long time. I don't remember when that was.
Unix operating system.
BSD. I didn't make a careful distinction there. But that was quite a big transition, right? They used to have a closed source operating system, and then they decided, oh, this isn't working. It's a big decision to make, right? Oh, we have this closed source operating system that we've been working on. It's not working very well. There's a Mac OS, and then they switched to an open source operating system and decided to build their GUI interface on top of that, the BSD operating system, which I thought was Linux, but it's not, it's Unix. So that's a big surprise. That's a very old story now, but at the time that was big. I thought it was a big story. I was really surprised. right? There's this one, this is a very popular one, the GPL license, the MIT license, the Mozilla license, and so on. So you see those a lot. You'll see examples of those licenses a lot. If you want to contribute to an open source software project, or you want to start one yourself, there's some ideas for you. Right after this, so somebody decided to release the Snake game as an open source piece of software, right? And that's what you're working on. So you're trying to modify somebody else's open source software. And maybe you have the idea of having your own open source project. And these are just some ideas, right? I think if you have an idea for an open source project, the first step, what would the first step be if you had an idea for your own project? Very first step. Any ideas? What would be the first thing you would do? I mean, the first thing you would do is to look to see if somebody else has solved that problem and already released a version of that idea. There are so many now that I think finding something new is very challenging. But guess what? You know, if you talk to the lecturers in this department, a lot of them will have ideas about projects that have never been done before. That's kind of what research is, right? Research is trying to work on things that are new. That's basically what research is, trying to solve unsolved problems. Right? And there are different funding mechanisms to open source software. You can contribute to an existing project, right? You see a lot of existing projects on GitHub. I can't keep track, like I don't know how many existing projects are on GitHub, but I guess there are millions of them now. Not sure. Most projects have a README file to look at as your point of your first thing to read. And there are often sections about how to contribute, right? If you're looking at contributing to an existing project, there should be some documents or documentation of the steps that are necessary in order to contribute to the project. Right? You all know about version control now. Every product has kind of a set of rules. Maybe they have, if it's a good project, they're going to have coding conventions. If it's a bad project, they won't and don't work on that project. Choose a new one. And each project will have a kind of etiquette, right? How you communicate. Maybe there's a set of comment conventions too. And there are lots of different avenues to get involved, like look at the current chat, right? There'll be a chat room for developers. You can talk to other developers to ask how you can help. You can use the existing versions. You can fix a bug and write some unit tests or some integration tests to show that you fixed the bug. This will be your the first thing that you'll be asked to do when you start a new job. Is you'll be given a piece of software and you'll be asked to fix the bugs, which is why we're going to talk about debugging. And there are lots of organizational documentation about open issues, right, on GitHub, right? There's color coding to indicate the status of different features and different bugs and what needs to be fixed and what's broken and what's working. And there are lots of different communication media. I guess this might be a little bit outdated in some ways. I think now Discord is kind of a very popular platform for this type of communication. I don't think it's here any, I guess you could call it a threaded discussion forum, right, and a community communications. And there are some other things like Discord, some competing software applications. And as you'll know, when you start a new project, there is a steep learning curve for big projects. You know, it's very difficult to start a new role and start working on a very big project. It's very difficult, actually. I mean, there's no way around it. It is just difficult because you typically have thousands of classes. So a project with thousands of classes, and you're trying to understand how that software works. And it is really difficult. But you can apply the principles in this module to help you with that. And yeah, understanding the project structure. In my experience, you have something like a 6-month grace period. In other words, you start a job and you're not expected to produce any miracles in your first 6 months. You're given kind of 6 months to learn the existing code base until you are ready to really start fixing bugs, adding new features, and making good contributions. So don't panic. Okay, and there are some resources for contributing to an open source project. And there's lots of reading, possible supplementary reading and so on. Are there any questions about libraries, open source software, and that sort of thing? I went a little bit fast because I thought, okay, you know, this is all stuff I think you're familiar with already, so it doesn't need lots of details. Any questions? Okay. So we'll continue in 10-ish minutes on the next topic, which is debugging.